Hey guys, welcome to Concept and Coding, and this is Shreyansh. So today we are going to very important topic in Java memory management, right? And before we start, so I want to say that please excuse my voice. I have a little bit cold, so I'm sorry for that. So here if you see that till now we have covered a basics like how to create a class, how to create a primitive data types, how to create an object, right? How to call a method. So this thing should comes to your mind, right? Hey Shreyansh, how do we manage? How do we the memories are allocated to them, right? So let's understand this today because this is very important interview questions, and plus when you start working in the company, you will see that how much importance is given to this. Okay, so now let's start this. So there are two types of memory. When I'm saying memory, I'm talking about RAM, right? So there are two types of memory which Java creates: stack and heap. And when we are talking about the memory management, who manages this memory? JVM. JVM is the one which manages this memory, right? And it divides the memory into two parts, stack and heap, and it stores different type of data inside it. So let's see first what kind of data is stored in a stack and what kind of data is stored in heap. So let's say this is your stack. Now here if you see that I am creating multiple copies of it, I'll tell you why. And let's say this is your heap. So generally heap has more memory than stack. Okay, and it's only have one copy. Now what kind of data is stored inside a stack? So first of all, it is stored temporary variables, right? So let's say you have created a method inside a block and you created a variable int a equals to 10. So its life is very temporary within this open bracket and closing bracket. After that it got destroyed. So this is known as temporary variables, right? So all temporary variables are stored inside this stack. Okay. Then separate memory block for method. So whenever a method is being created, so let's say this is inside of one particular method, public get something. So for each method there is a block memory frame, you can say that stores, and inside that method whatever the variables, whatever the reference it's created, it will store inside this memory frame. Okay, so I'll tell you an example with this one, but first let's go through this what kind of data is stored, and we will see the example. It will clarify you more. Okay, but let's see this. Store primitive data type. So this is also nothing but a primitive data type. So primitive data type is stored within a stack. Store reference of the heap object. Whenever you create an object like new with the new keyword, whenever you create an object, it is stored inside a heap, its memory. But its reference of object is stored in the stack. So these type of reference I will tell you later, but first understand what kind of data we stored. So but there are different type of reference: strong reference, weak reference, soft reference, phantom references, right? So I'll tell you later, but first understand what kind of data we stored. Each thread has its own stack memory. So now you know that. That's why I have created multiple copies of stack, because each thread, so this is let's say thread 1 has its own stack memory. This is thread 2 has its own stack memory. Thread 3 has own stack memory. Thread 4 has its own. But if you see that all the threads share a common heap memory. Okay. Variables within a scope is only visible, and as soon as variables goes out of the scope, it get deleted from the stack in the LIFO order. So what I mean to say is that everything is here in the stack is within a scope. Everything has a scope. I will tell you how. So just wait it for an example. You will get to know how this LIFO order is performed and what is meant by the scope. When the stack memory goes full, you will get this error, stack overflow error. Okay, now let's understand this with the example, right? This is very simple class. If you see, I have created a class memory management, and I have one public static void main. So it's one method. Okay, so this method has one primitive data type, one object, one string literal, right? One object I created to invoke this another method, and I'm doing an invoking of this method. And then you can say that this has invoked this, and inside this I have another reference to an object, another string literal, and another string object. This is not a string literal, so this is a string object using new keyword. So it's a very simple class. We have covered methods, variables, right? So you should be easily understanding this what I have written. But now let's understand this, how memory is stored for this one. So now let's create a stack. So let's say this is our stack, and let's say this is our heap memory. Heap memory is always larger than a stack. And so here let's see this. First of all, main method is invoked. Whenever the main method is invoked, I told you for each method a block of memory is stored. So let's say I have stored this block memory. This is for main. So this is one scope for the main, this frame. You can call this as one frame of memory. For which method? Main. And all the variables which are created inside this main method, it would be stored in its block. Okay. So this is its scope. So now let's say main method is called. We have created its memory. Now I have created a primitive variable. Primitive variable 1, 10. So I have stored it here. Primitive variable 10. So as you know that primitive variable doesn't hold any reference, it stored the value itself. So it is stored into this memory of this scope. The second is I am creating a new object, new person. So one memory is created here. Let's say this is your object, person object, and this person object has a reference. Who is storing the reference? Person obj. So it has one person obj. So this holds a reference to this memory. Okay. Now I am creating one string literal. So as you already know from the previous variable class that string literals stores the data into the string pool. And where does string pool stores? String pool is saved inside the heap only. So there is something called string pool. So whenever you are creating a literal, a string literal, so it would be stored here 24. Okay. And what is the reference? String literal. So it will create a reference variable string literal, and it is storing a reference to this 24. Okay. Now the third line is new memory management. So see, I am creating one more object now. So let's create one more object here. I have created one more object. What is the object? Memory management. Memory management object, and its reference is inside mem obj in the same main one, right? So it would be inside this only, mem obj. So currently if you see that all are within a scope, so scope is still going on, scope is not yet finished. Okay. So within a scope you can access all the variables, right? Within a scope. So this is a scope. Within a scope you have access to all the variables. So now mem obj is storing a reference to memory management object. Now I am invoking a method, memory management test, and passing this reference. So now you see that I am creating another method. So for each method it will create a new reference. So I am creating another frame. So this frame is for which method? Memory management test method. So this scope is for memory management test method. This scope is for main, and now this is for this one. So this is its this method frame, memory frame. So first of all, it has this person obj. It has this person obj, and what reference it has? So we pass the reference of this one, new person. So new person is here. So this is has reference to this one only. Okay. Now see, I have created another reference which is pointing to which object? Whatever the person object is pointing to. So I have created another reference, person obj2. Person obj2, and it is pointing to the same memory which person obj was pointing. Person obj was pointing to this, so it was also pointing to this one. Same. Okay. Now I have created one more string literal 24. So whenever as you know from the previous class, whenever you created a string literal, first it will check into the string pool. Oh, is this literal present? 24 is present. If yes, it will not create new, it will use the same. So it will create string literal 2 reference, string literal 2, and it point to the same from the string pool itself, 24. Then it's create a string literal 3, and it's not a literal, it's a new object because I'm using a new keyword. So it create a new object which is a string object and has the value 24, but it is inside a new, this one, a string literal 3, and it's storing this reference here. Now if you see that I have got a closing bracket. Whenever you get a closing bracket means scope is finished. Whenever the scope is finished, you have to delete all the variables or references created within that scope. So now this scope is finished for the memory management test. When the memory management scope is finished, it will delete this scope. It will delete this scope. Right. So now if you see that it's going in the LIFO manner, last in first out. So this one was the added last after main, but it is the first one to get deleted. When this scope is get deleted, so all this will also get removed. So now this is removed. So this reference no more exists. After that, this get removed. So this reference will also get removed. Okay. Now after that, this will get removed. Inside this will get removed, right? So this reference will also get removed. After that, this will get also removed. So its reference will also be removed. So now you see that it has done remove this memory management test method frame, and all the variables we have created, we have removed in a LIFO manner. We have cleaned up. Okay. Now it moved to here. Now the control come back to here. This method is completed. Now main method closing bracket has been reached. Now main method closing bracket has been reached means main method scope is also finished. So we are removing this also. When we are removing this, so what we are doing is we have to remove this mem_obj. When mem_obj is removed, we have to delete this reference. So this reference is removed. Then we remove string literal, and this reference will be deleted. Okay. Then person obj reference is deleted. Its reference will also be deleted. Then this value will be deleted. So now if you see that the method execution is completed, right? Stack is empty and everything is done. But now you have noticed one thing. Hey Shreyansh, what we have deleted the references which was pointing, but what about this objects which now created in the heap? How we will delete those? Because their reference, when their references was deleted, so whatever was pointing that, we have deleted that reference. But now these objects are left in the heap. Who will clean this up? That's where the garbage collector comes into the picture. Garbage collector is used to delete the unreferenced object from the heap. So now for this object, is there any reference from the stack? No, there is no reference. So garbage collector will remove this. Now it will check, hey, is there any reference? Is anybody referencing? No, nobody is referencing. This will also be freed up. Hey, for person object, is there anybody referencing? No, nobody is referencing. This will also be freed up. Okay. Similarly for the string pool, if it is not used afterward, it would be removed. Right. So this all will be done by garbage collector. Garbage collector runs periodically. Right. JVM controls when to run the garbage collector. So see, there is a command called system.gc. So in your application code, if you write this command, you are telling that, hey, run the garbage collector, and garbage collector will try to scan the heap. Hey, what all object there is no reference. If it find any object for which there is no reference, it will delete it. But JVM says that there is no guarantee that even if you type this, I will run the GC. So running the garbage collector is totally depend upon JVM. So JVM has full control over garbage collector, whether I should run it or when to run it. Okay. So even though you write it, there is no guarantee that garbage collector will run, and that's why it is called as automatic memory management. Right. So you don't have to worry about freeing up the memory. JVM takes care of it automatically. It periodically, it keeps on checking the heap memory, and if it seems that okay, heap memory is filling up fast, so it will run the garbage collector more periodically, more faster. If it seems that okay, I have sufficient space, no need to worry, JVM may run garbage collector very less. Okay, so you understand that. So now you have understood this stack memory, how it stores the block, how it stores the variable, how it stores the primitive data type, how it stores the references. Now I'll tell you about this strong reference, weak reference. Okay, and also you have already know about how each thread its own stack memory. Variables within a scope is only visible, and as soon as the variable goes out of the scope, it gets deleted in leaf order. I think you get it by the scope, right? So this variable is not visible inside this scope, right? So each variable is visible within its own scope. And when stack memory goes full, it throws stack overflow error. Okay, so now let's understand this. What are the different type of references? So in a simple way, I have told you this way that for a stack, this is a heap, this is a stack, this is heap. Heap stores the object, this stores the reference of object. Reference of object. So now let's say this example I have created here. Person obj equals to new person. Okay, so I have created an object of person, and P object is the reference to it. So this is P obj. It's a reference to this. This is known as a strong reference, right? So this is known as a strong reference, like how we are using it as of today mostly. This is known as a strong reference. So when garbage collector invokes, now garbage collector runs, now it sees that hey, is there anyone who is referencing to this object? It will see that yes, there is a strong reference. So it will not delete this. It will survive. Okay. Second is weak reference. Weak reference. How you create a weak reference? There is a class called weak reference. You want to create a weak reference of person. Now you are saying that okay, this is weak p obj equals to new weak reference of person, and you are creating a new object, new person object. Okay, now see this. Whenever you create an object like this, so you are creating a new person object. Let's say you are creating another new person object. Okay, so this is another p person object, but you are making a weak reference, right? You are creating it a weak reference. So now here you are creating a one more weak p obj, weak p obj. So there is a reference, but it's a weak. What does it weak means? Weak means that as soon as the garbage collector runs, as soon as garbage collector get invoked, it will free up this space, right? So it's not like a strong. A strong says that, hey, garbage collector, don't delete my object because I have a strong reference. Somebody is using it. But weak reference is that till garbage collector is not run, I am able to access it. But let's say garbage collector runs, it is not mandating the garbage collector that you cannot free it up. Hey, if you run, freed it up, right? And if it try to access, what value it will get? Null. Okay, so that's the difference between strong and weak. Strong tells the garbage collector that do not delete this, I have a reference. But weak says that I have a reference, I can access the value, but if you runs, you can free it up, right? As soon as you run, you can you can make it free, and if I try to access it after that, I might get null value. So that's weak. And there is something called soft reference. Soft reference is a type of weak reference, right? What it tells is, hey garbage collector, you are allowed to free it up even though I have a soft reference, but only do it when it is very, very, very urgent. Very, very urgent means that there is no more space and you have to create a space. Then go ahead, you can remove it. No problem. Okay. So only difference between weak and soft is like, weak is like as soon as garbage collector will run, it will feed this. It will remove this object. Soft reference tells that yes, garbage collector, you are allowed to free this, but do it if it is very, very urgent and you need the space very urgent. Okay. So that's the only difference. Okay. So generally we hardly use this. In the company, we are mostly using a strong reference part. Okay, but it's good to know this. We have this type of references also: weak reference, soft reference. A strong reference, if there is a strong reference present to an object, this object will never get deleted till a strong reference is present. If weak reference is present, as soon as garbage collector will run, it will remove this. No matter weak reference is present or not, and if it try to access it, it will get null value. If it is a soft reference, GC might decide that, okay, I have sufficient space, let's keep it alive. So it's upon GC totally. It is allowed to remove it if it want. But GC will say that, okay, I have sufficient space, let it live for some more time. Right? So soft is just this. But totally GC is allowed to free it up, but only do if there is a very shortage of space. Okay? Understood this one? References, different type of references. Now, before we jump into the heap, very, very important, I just want to tell you that how the reference can be changed. So this is a heap. This is a stack. Let's say I created this one. Person obj equals to new person. So what will happen in this case? A person object will be created. Obj reference will be there in the stack. It will pointing to this. So first, if I do this, obj equals to null. Means what I am doing is I am making this, removing this reference and storing obj null value. So now garbage collector can invoke and remove this. Okay. Another way is, let's say so this is one object and currently it is pointing to this one. Okay. So currently it is pointing to this one. Now I am creating another object, person obj2 equals to new person. Okay. So what I am doing is I am creating another object. So this is person object 1. This is person object 2. I am creating a new object and obj2 is the one. So this is obj1. Let's say this is obj2. This is storing reference to this one. If I do this, obj1, or this is let's say 1, obj1 equals to obj2. So means what I am doing is obj1 is now storing the reference of this one. Obj1 equals to obj2. So this one. So now here if you see that garbage collector, when garbage collector invokes, it will feed up this because there is no reference to this one. So there are different ways like garbage collector can get invoked, right? So there is no reference to this one, it get invokes and you can manage the references through which, and if heap is getting full also, then garbage collector get also invoked. Okay. So whenever object is not present, no reference is present, it is allowed to freed up the memory by the garbage collector. Okay. So now we know how what kind of data stack store, what kind of data heap stores. Now get little bit more into the heap memory, right? Now let's go into the heap memory. I hope you are finding this topic very, very interesting, guys. So heap memory is divided into two parts, which is young generation and old generation. And there is one more part which is generally known as non-heap. Metaspace. Okay, in the previous version of Java, I think before Java 7, it is called prem-gem, but now it is no more used. It is used the Metaspace. It is called as Metaspace. Okay, so this is not a part of heap memory. So heap is generally, so this is your heap memory, which is divided into two parts, young generation and old generation. So young generation is further divided into three parts. Eden, S0, S1. This is known as survivors. Survivor space. And this is Eden. Okay. Now let's understand this. Very, very simple, right? But very, very interesting. Now let's see how when you create an object, where it stores first. So this is, let's say, your young generation. This is your old generation. This is your Eden. This is your S0, survivor 1, S0, S1. Okay. Now I am creating an object 1. I am creating a new object 1. So first of all, whenever you created a new object, it goes inside Eden. Okay. This is your object 1. I am writing O1 to save a space. So it is object 1. Let's say I created another object, object 2, object 3, object 4, object 5. So I have created 5 objects. So currently everything was empty. So I have created 5 objects. Object 2, object 3, object 4, object 5. So 5 objects are created inside a Eden. Now Let's say after a periodic time, after some time, garbage collector got invoked. So first time garbage collector invokes. Now garbage collector do two things. So there is something called an algorithm called mark and sweep algorithm. Mark and sweep algo. So what it will do is, as a part of first step mark, it will mark all the objects which is no more reference, and it is allowed to delete. So let's say object 2 and object 5 is something, there is no reference. There is no reference like this, and it is allowed to be deleted. There is no reference. Let's say object 2. So it mark it like, okay, object 2 and object 5 are allowed to be deleted. There is no reference. Then there is something called sweep algo. Now what this sweep algo will do is, it do two things. It will first remove this. It remove this from the memory, and what it will do is, it will sweep this the surviving objects into one of this survivor stack. You can say that memory place. So now here this O1, O3, O4 will come into S0. Okay, and it will be removed from here, and this 2 will get deleted, and it will age will be added. So age is its age is 1, its age is 1, age is 1. So means their age is increasing, right? So this process is called minor GC, minor garbage collector, because it's very fast. It happen very periodically. Now let's say second time. Now let's say another object created before any garbage collector runs. Another object created, let's say obj6, obj7. So where does obj6 and obj7 will be created? Let's say here obj6, obj7. Okay, because every time a new object is created, it is created inside a hidden only. Now let's say garbage collector got invoked after this. So first it will do mark. So now it will do a mark into all Eden, S0, S1, like whatever the objects. Hey, which one there is no reference? So let's say obj7 there is no reference, so it's marking it. obj4 there is no reference, it is marking it. Now they are eligible for deleting. Now sweep will happen. So what sweep will do is, it will delete this, remove from the memory, and what it will do is that in the other, so alternatively, first it put into S09, now it will put into S1. So obj6, so object 6 is put here. Now its age is 1. Object 1 is put here. Its age was 1. Now it's got age increased to 2. ob3, its age was 1. Now its age is 2 again, plus 1. And this will get removed. Object 6 is already there with age 1. So this is Eden get freed up. This got removed, and this got freed up. So if you see that at a point, Eden would be free after the garbage collector, and one of the S0 and S1 would be free. Okay, and alternatively we put the data into S0, S1, and we increase their age. Now let's say I have set my threshold. Threshold value as like age 3. Whenever age 3 is reached, I have to promote them. I will tell you what does it mean. So now let's see, I have created one more object. Let's say object 8. So in which memory object will be created newly? Here, object 8. Okay, I have created, let's say, object 9. Now third time garbage collector runs. Now garbage collector runs, what it will do? It will first mark the objects which there is no reference. So now let's say it's marking that, okay, I have to delete this one, I have to delete this one. Okay, now the sweep will happen, and what sweep will do is, it will delete this, it will delete this, freed up the space, and what it will do is, it will put object 9 from Eden to this age 1, and from S2 it will bring object 6, age is 1 here, then it will to object 1, age was 2, now age will become 3. Now here if you see that one thing, so let's first clean up this. Object 9 is there, object 6 has been moved to S0, this freed up, and object 1 has been moved to S0, this one. Now here if you see that I have defined a threshold age of 3, and after 3 I have to do promotion. So what does it? So now here if you see that object 1 has reached its age, it has survived this much time. So whenever it survives a particular threshold, it has to do a promotion. And what promotion means is this object will be now moved to old generation. This object 1 will be now moved to old generation. Okay. So now in the old generation, only difference is that here it is called minor GC. Here it is called major GC whenever GC runs. Why? Because it, first of all, whenever the GC runs here, it don't run too periodically. Right? Maybe let's say here it is run every one time in 10 seconds. Let's say, I'm just saying it. Right? But let's say in old generation, it might be running one time only in half an hour. I'm just saying that theoretically that here the GC runs very less periodically. Very less as compared to the young. And also, whatever the objects are present into old generation, they are kind of a big objects, right? They are used too frequently, right? So it takes a lot of time. So these are like faster as your young generation, right? So you can say that objects created, deleted. So it's very fast. But old generation generally happen is like there are a lot of references because they are alive from so long. They are alive from so long, so there could be so many references pointing to them and all, right? And they might also have a further references to them. So generally this process is garbage collection is little bit time taking than young generation, but it do the same thing. It first do mark if there is no reference and then delete it. But here the garbage collection process is called major GC. Here it was called minor GC. You understood that? How heap memory is divided into young generation and old generation, and young generation we have Eden and survivor space. Now there is something called Metaspace, right? So this is a outside of the heap. What data it will store? Your class variables. I think you have seen the variable topic, right? You have know what is class variables. Every object which you create through static, that is class variables. So it is store class variables. It is store class metadata. Class metadata means it store information about the class from which objects can be created, right? It store constants, right? You define, right, static final. So these are constant. So all this kind of data, metadata information, constant, class variables are stored into the Metaspace, right? So as soon as like Java JVM need to load certain class, it will load it here. As soon as JVM doesn't need any class, so it will remove it from here, right? But this is important. Now we have understood about the heap, right? Young, Eden, survivor, old. Old generation is also known as tenured. Permanent generation, so that is PRM, PAM, GEM. It is used to be earlier one. Now we call it Metaspace. I have already told you, right? So this was in the old Java versions. I think before Java 7, I think you can check it once. I think it is before Java 7. It is a PremGem, and the major difference between PremGem and Metaspace, I think from Java 7 or Java 8, we are using Metaspace, right? But here the major difference between them is like PremGem was a part of heap. So you have young, you have old, then you have PremGem. So it's a part of a heap memory and it is not expandable. So as soon as it will get filled up, you will get out of memory error. But here Metaspace is out of this heap is now only young and old, and Metaspace is separate. That's why it is called as non-heap, and it is expandable as you require. Okay, so that's the major difference, but the kind of data they stored is kind of same. Now let's understand about the garbage collector algorithm, which is we are kind of our last topic here today. Garbage collector. So I think you already know by here what is garbage collector, how it get invoked, like what is the purpose of using the garbage collector. And one of the algorithm I have already told you, the mark and sweep algorithm. So as a part of first phase, mark, it will identify what all objects need to be deleted, and the sweep, it will just remove those objects from the memory. Right? So there is something called mark and sweep with compaction, compact memory. So what's the difference here is simple, nothing much. So here if you see that, let's say this space, memory space, heap. So here you have one object which is identified that it can be deleted. There are objects here, let's say. And during the mark, I have identified what all objects need to be deleted. Let's say I have identified this, identified this, identified this. And as part of sweep, I deleted it. So I have deleted this. Now here if you see that how our memory is generally would be like this. So one data is here, one data is here, one data is here. But there are certain memory segments which are freed up here. There are certain memory segments which are freed up here. So with compaction, what happen is it will bring the objects into sequential, right? It compact it so that we have a memory fragment in a sequential form later, so that any new object it can be added later. Otherwise it would be very difficult to put an object in this fragments, right? So what it will do is it compact the remaining objects which survive, and so that we have a free of space at the last, and it would be used to put an object there. Okay, this is known as mark and sweep with compaction. Now there are different versions of GC. First is serial GC. Second is parallel GC. Third is concurrent, mark and sweep. This is CMS. And fourth is G1 garbage collector. This is the default version of garbage collector in Java 8. Okay, now I'll tell you, this is very important, understand this. Serial GC. Now you know that garbage collector is used to remove up the memory from the heap, from young and old both, right? So serial GC is that only one thread is used, and this thread will work. Let's say garbage collector initiated, and this will work and freed up the space. Only one thread, let's say. So this is called minor GC and it is called major GC. So when the minor GC will get invoked, only one thread would be working. When major GC will invoke, only one thread would be working, only one GC thread. So what is the disadvantage is, first of all, whenever you are only one thread is working, it definitely work would be slow. So it would be little bit slow. Second thing is GC is very expensive. Why GC is very expensive? Because whenever the GC work start, all application threads will get paused. So that's why we call that the world stop when the garbage collector runs. So let's say your application is running. As soon as the garbage collector runs, your application will become paused. Now garbage collector will complete its work, and after that it will resume. So if GC is slow, then definitely your application would become slow because they are pausing too many times. So that's why GC is very expensive task, because when the GC work start, all application thread will pause. So this is one of the disadvantage of serial GC, that only one thread doing the work of cleanup. So in the Java 8, the parallel GC is used. In this, depending upon the core, let's say if you have 2 core CPU, 4 core, so this many threads got initiated for the garbage collector and they work parallelly, right? So when there are more threads, definitely it would be little bit fast and there would be less pause time, but still there is a pause time, right? But only thing is multiple threads are working to free up the space, so you will get a little bit less pause time, because the work of cleanup would be done little bit faster. But still, this is, you can say that in the latest J17 and all, there has been work has been done to further improve this through concurrent mark and sweep. Concurrent mark and sweep says that, okay, while your application threads are working, this is your application thread, concurrently GC threads are also working. So it's a concurrent GC thread. So your application thread is working and in parallel GC thread is also working. No one is stopping. So application threads are not stopping because of GC threads, right? But it's not 100% guarantee, right? JVM doesn't guarantee that your application thread will not stop. Only it says that I will try my best that your application threads will not stop. I will try to do concurrent mark and sweep. Concurrent cleanup I will try to do, but I don't guarantee 100%. And also there is no memory compaction happens. So whatever the memory got freed up, so let's say there is some segment freed up, there is certain memory segment, so no compaction happens in this. So then there is a further improvement is like G1. So G1, you can say that the better version of this, where it says that, okay, try to give you 100% that, okay, your application thread will not stop, and also it brings a compaction, that all the memory is bring together and all the freed up memory is added at last so that they can be used. So you got it. Currently Java 8 is using parallel GC, and there is a further, in the latest version of Java, there is a further chance that the pause time can be reduced to a very minimal, so that your throughput increase and latency decrease. When your throughput increase means earlier your application can process 1000 requests per minute, let's say. Now because there is less pause time, you can process, let's say, 1500 requests per minute. So your throughput will increase. Definitely when what will happen is, when your throughput increases means you have threads are not pausing. So pause time has been removed. So definitely your latency will go down. You will see the advantage. Okay. So that's pretty much I have for you in memory management and garbage collector. Very, very important topic. Please go through one more time. You will understand it better, right? And yeah, I think that's it. If any doubt, please feel free to ping me in the comment section. I will try to resolve your doubt as soon as possible. Thank you guys. Bye.